Okay. So yeah, I think in the last series, I think we're looking. The last two sessions, we are primarily looking at comparison of various components within AWS, Azure, and GCP, and also we try to get more, try to get understand more about the GCP in comparison with AWS and Azure. So in that aspect, yeah, we already looked at various components. I'm not going through that again because we've already gone through that. So accounts, we looked at the regions and zones and the compute, both infrastructure and container orchestrators. Database we saw, and also messaging we saw, web application we saw, networking we discussed, storage. So I think yeah, we will start from here because the next is the data. So this is related. So let's start from storage. So I think yeah, from storage angle, yeah, for object storage, a lot of storage options available in all the cloud vendors, like starting from object storage to disk storage to file storage to various options are there in storage category. But in that, object storage is most used just because of the cost, and also it gives other advantages of uh, storing the images and other data. So the non-structured data also you can store here, like images, HTML, contents, raw text, logs, everything you can store here. So object storage is a cheaper solution, and the equivalent options available in AWS or S3. In Azure is blob storage. In GCP it is called cloud storage or cloud storage for Firebase. So the Firebase is primarily for a mobile implementation angle. So it is a bit different, but I think more or less it is conceptually the same. But just for it is mobile specific, there are some optimizations on this cloud storage for Firebase. Otherwise, the main is cloud storage, which is for all the purposes. But if you have data specific to mobile, then you can use the cloud storage for Firebase. Um, and there's the object storage. And coming to the like hard disk or the disk storage category, AWS has EBS, Elastic Block Storage. Azure has managed disks, and GCP has a persistent disk or local SSD. This category is primarily just like your hard disk in your laptop. So you'll get a C drive, D drive. So you can add additional C drive will come by default, which is a local storage. But generally, once you restart your your system or OS, the data could go away. And if you crash, if you delete the VM, for example, the data will go away. But if you can think this as like your external hard disk. So you can associate, you can store data into this external hard disk, and you can link this hard disk, like how you associate a hard disk to various laptops, from laptop A to laptop B to laptop C. You can also associate this disk, or you can mount this disk to various VMs. So that way it is not associated to a VM. You can anytime attach or detach and reattach to another VM. So it is like completely like a hard disk. So in that category, you have these three options here. In GCP especially, the local SSD the data will be gone if you clear the cache. But if you want a permanent storage, then persistent disk is your solution. And coming to the file storage, like your normal text files, probably following the NFS protocol. So probably NFS protocol is probably used for this file storage. And here in this category in AWS you have EFS, Elastic File System. In Azure it is Azure Files or OneDrive for business. And for GCP it is FileStore or Google Drive Enterprise. So these are the options you have for file storage. And so that's about the basic storage options. But if you're looking for archiving and backup, so every requirement should be different for data storage. If you're looking for if you're looking for a low cost storage option, then we have various tiers in this storage category in all the cloud vendors. For example, AWS is S3 infrequent access. From the name, it's infrequent access login. Whatever data you don't frequently use it, so you put it in infrequent access. So that way your cost is minimal compared to using a normal S3, for example. So it's a category within S3, but just that it is primarily for infrequently accessed data. So and also equivalent to that in Azure is normal storage is blob storage, but whereas if you're looking for a low cost, it is storage pool tier. So same thing in GCP, it is cloud storage. Here it is cloud storage nearline. And further low cost, if you're looking at archival kind of a requirement, then Glacier and Deep Archive in AWS again comes under S3. And in Azure, like blob storage equivalent here is storage access tier, and for GCP it is cloud storage, cold line, and archive. So the difference is here nearline, which is for normal usage, low cost normal usage. Cold line is for archival purposes. So and also you have something called even if you cold line is it is not really archive, but actually it's more it take more time to retrieve the data compared to nearline. But archive is perfectly meant for archival. Like example, you'll retrieve this once in a year or twice a year. So for that kind of a archival data storage, then you can use archive. Google use archive, and also some backup. They have. I didn't see any backup equivalents available in GCP for storage, but at least in these two we have AWS backup and Azure backup is available. And data transfer. Again, this is a very common use case where you want to transfer the data to storage from your on-premise. So first data should be transferred. Only then, yeah, you can store and retrieve data from the cloud storage. So first, especially when some company wants to migrate to cloud, first they need to, the first time, one time actually, they need to transfer their existing data from their on-premise DBs or storage options to cloud. So in that category of data transfer use cases, in AWS it's import export disk, and in Azure it is Azure import export, and in GCP it is transfer appliance. So, but again, if you're looking for a very huge data like petabyte level, then import export Snowball and Snowball Edge, Snowball Mobile. In Azure it is DataBox, and in GCP again it is transfer appliance. Then hybrid storage category, it is a recent addition in this space. So generally, one common problem in this storage is that the retrieval of data from your on-premise to cloud is generally it takes more time because there is a latency that will be there to fetch the data from your on-premise for your on-premise system from cloud. The data should travel across the network. So you have to avoid the latency issues. So all these cloud vendors are now trying to come up with solutions which are more integrated to your on-premise system with the caching feature built in. So which means this caching feature will cache the most frequently used data, but behind the scenes they will push the data to cloud. So they will have, like for example, AWS Storage Gateway is the one feature where it has integration behind the scenes with S3. But the storage gateway as such is a device which will be set up on your on-premise data center. So every time you store a file, it will be stored in the storage gateway, cached, and also a copy will be stored in S3 behind the scenes. So every time when someone retrieves this file, if the data is already there in the cache in on-premise, it will retrieve the data faster rather than going to cloud and fetching the data. And if there are incremental changes or amendments happen to this file, for example, it will be stored in this on-premise device itself, but behind the scenes, it will push the data to cloud. So that kind of a hybrid model is what is this combination. So storage gateway is the AWS answer. Store Simple. The Store Simple is an acquired company by Azure, but yeah, so now it's Azure product. Azure Store Simple. I don't see anything equivalent in GCP yet. Same thing here for cloud storage and primarily for object storage category, which is like S3 equivalent solutions. But file storage, NFS, then file storage, then data sync in AWS and file sync. So yeah, that's storage category here. So now let's get to the big data and analytics space. This is a very growing, very fastly growing space nowadays. Again, this big data and analytics category, if you see, there are various categories like data is one, big data processing. Like first you need to get the data, and you have to store it somewhere. So the data warehouse is like first you collect the data and store it somewhere, and then create a pipeline and do some processing, and then there is also a variation in this called ETL or data orchestration, and finally analytics and visualization. So that's how the big data space is now uh, coming into. So there are, I mean, to answer Venkat's question, so you need to see in which area the data architect should know this end to end, but if you're a developer, then we should see in which area the skill sets you'll based on it you'll fit in. So you need not be knowing end to end. Also in the data space, probably you could be an expert in just analytics, or you could be expert in ETL, or you could be expert in big data or data warehouse. But as an architect, you should know more or less at a high level everything. So that is
So,
it.
but here the Redshift equivalent is Synopsys Analytics.
Yeah,
Oh,
correct.
okay. I thought it was Databricks. No, okay.
Databricks is more at this level. Data streaming. I mean, it depends. It's not a data warehouse. Then it is Synapse Analytics. But where EMR is where Databricks is equivalent to.
Okay.
Yeah, yeah. So let's start with data warehouse. The data warehouse. So you'll have various sources from which you need to pick the data. In that space, AWS Redshift is a data warehouse component, and in Azure it is Synapse Analytics, and GCP is BigQuery.
So,
Uh,
Venkat, so are you looking at the Synapse Analytics, or are you looking at Databricks on your
No,
side?
it's the entire data flow. That's I am crossing this Synapse also because the data warehouse is the main for the data flow actually, and Databricks it's another. It's like a ETL. We can use as an ETL in that data flow. At
Okay.
presently, I am doing that actually. Yeah.
Okay.
Yeah. So I think first is like you have to collect the data and put it in one common location. So it's kind of a warehouse. So you collect the data from various sources. Generally, the Redshift or equivalents. So they will have various connectors to pull the data from various sources, and also store it in one common pool. So that is what is this data warehouse category is. So yeah, Redshift is the most popular tool of the AWS space. Azure Synapse Analytics again is an acquired product from Azure is it's an acquired company like Databricks, so they are into this space. One key finding is that this, I mean, Azure is they don't have in-house built tools. They are it's more at least in this data space at least. They are more or less now to compete with the market. Now they're in a hiring like acquiring spree where they're acquiring a lot of companies in this space, starting from ML to the data warehouse to the pipelines. So Synapse Analytics is also one such acquired company from by Azure, and the GCP space is BigQuery. BigQuery is just reading an article where all the I mean, BigQuery is all the popular Google products like YouTube, Gmail. So they're all already using BigQuery behind the scenes. So it's kind of a already proven or tested product for within Google, considering the Google's capacity. We can imagine that it is already proven tested for that area. So yeah, I think that's how this marketing is also happening for BigQuery here. But yeah, I think this is where the BigQuery is something which can crunch a lot of huge petabytes of data and also give you more consolidation of all the data, and the queries can be run very faster. So yeah, I think more or less Redshift is also equally popular in the AWS area. Next, coming to the big data or lake formation or data lake. There's a data warehouse and data lake. I think slowly the the meaning is getting kind of bundled nowadays. I think data warehouse and data lake is like becoming synonyms nowadays. But yeah, but at least the lake formation is AWS lake formation is primarily for sharing the data from various sources and pulling it in one place. So that kind of a model is what is lake data lake. So in that area, that space AWS lake formation, and Azure is Azure data share. I didn't find any equivalent in this lake formation category. I didn't find any equivalent here. Okay, the next is that's warehouse or data lake. The next is big data processing. This is where actually you have this starts with the assumption that data is already there somewhere, and now you need to take it do some processing and store it or transform it and then put it somewhere. And primarily it uses Hadoop or Spark based or streaming. I mean, there are a lot of variations in this. Like Hadoop is an older option now, and there is some more or less now replaced with Spark, Apache Spark, and Spark based analytics. And the more recent version is streaming, so you can get the data in real-time streaming. So that is even more advanced. But if you're looking for a cold data is like you already have data available. It's not real-time, but you already have the data and you have to crunch it. So for that, Spark-based would be a best suit. But if you're getting real-time data, then it is streaming would be a more hotline streaming. Is that category, the streaming is more popular. So yeah, in this space, AWS EMR, which supports all the like batching, streaming, and Spark-based analytics, both are supported, and also Hadoop. And in the Azure side, it is Databricks, so for streaming especially, and also for Spark, it is HD Insight, and GCP it is for streaming, it is data flow. So you have to form like like Databricks, you create a pipeline of the flow from source A to processing, like typical ETL flow. You will create a pipeline, and then and the source could be anything, or destination could be anything. But in between, there are a lot of logic to transform it. So that pipeline you can create using Dataflow. So equivalent to that is like similar to your Databricks. And in the Spark, so it is data proc. So data proc is primarily for Hadoop implementation and Spark implementation. So this is data proc is primarily meant in that space. And for data lake storage, so yeah, EMR can store data in EMR itself in AWS, and in Azure it is a data lake storage. And here I didn't find anything equivalent in data lake category. Then batch data processing. Here, I mean, this is like it could be real time or batch. So the batch we have EMR and AWS batch. Here it is Databricks, Azure Databricks, and for a few scenarios for batch only requirements you can use Azure batch. Here it is Dataproc and Dataflow combination. So streaming, something called for streaming is space, especially when the data is coming in. Keras is also the most popular tool. Keras is Firehose. The name Firehose, like you can yeah, it will sprinkle the water out, right? So it's similar to that. So where you can the data will come like how water will come in the fire hose, like you can create a pipeline and then you can push the data to various destinations. So such kind of a streaming requirement and pushing data to multiple destinations, kind of a requirement, Pyros will be a more suitable option. And Kinesis streams also for this space. In Azure, it is event hubs, Azure event hubs, especially when you're looking for storing the data temporarily and processing the data based on who is subscribing to this event hub. So there'll be what is similar to the uh, to, to Kafka equivalent in the open source world. So there will be multiple sources and multiple producers and multiple subscribers, and the data will be coming in real time to the event hub from various sources, and whoever is subscribed will get the data in real time to the event hubs. Yeah, the same in GCP space, it is data flow. So yeah, that's about the data warehouse and the big data processing. And coming to the ETL side, ETL or data orchestration is all more. I mean, ETL is kind of as we said, like ETL is changing slowly. It's nowadays called as data orchestration. Because it's not always ETL, right? It could be ELT also or ELP also. So yeah, so it depends on the requirement. So that's why it's called as data orchestration nowadays. So here in this concept where you have to manage the pipeline of data and also there will be workflows that will be there and you need to orchestrate the workflows. So in that category, in AWS we have data pipeline or glue. And in Azure space it is Azure Data Factory, and in GCP it is Cloud Data Fusion or Cloud Composer. So this is especially in this space where you can create like various from various storage options within GCP. It has connectors to various storage options, and also it has connectors to fetch the data from on-premise as well. So it also supports streaming and other things. It also supports connectors to various databases. So yeah, it has a lot of connectors, and using that it can change to get the data, transform it, and then probably put it into another storage or another application, or it could be another warehouse itself. It could be the destination. So yeah, various options are there here. And yeah, for all these things, you need to first discover the various data sources. So the discovery is becoming a challenge in the cloud space. Because I mean not a cloud space. It is primarily all the enterprises have one big problem, which is the various data sources. They in fact don't know where the source of data is available. So now, but they have the database, but they don't know what are the various sources from which they're getting the data. So that creates a big confusion in terms of to know whether a data is valid or not, or what is source of data. So and like is it coming from another application, or is it coming from a third party? So a lot of confusions are there in some enterprises which are very big, which are not very well managed. So in that area, so first is to discover the various sources of data. So in that, I think the toolings came very recently. The AWS grew in the AWS space, Azure Data Catalog, and similarly GCP is Cloud Data Catalog. So these catalogs are primarily, it will analyze the various sources of data and it will form a catalog so that anytime you can come and see what are the sources and where a given data is stored in which place. So it's like a summary view that you can get of your data sources. So that is one popular use case for a big company, especially. Yeah. So that's about the data orchestration or ETL side. So and very popular area is this analytics and visualization. So I mean, we have data, but again, it will be always good to see the data in proper graphs so that you can see the trend going up or down, or there are a lot of areas. It's not just histograms or pie charts or various categories. You can visualize the data. So all this analytics and visualization altogether is a bigger space in this big data category. Yeah, in this, a lot of tools are getting popular, especially uh, now the data is coming real time. So you need to form a data in real time, form a graph in real time. So earlier it was not the case. It will always a cold storage data, and then you will apply uh, analytics on the cold storage data. But yeah, that is not acceptable in this current world. So it's all streaming of data real time, and the analytics also should reflect in real time. So that kind of a category. So stream data processing, and also for that visualization part, the VA visualization, and then the next is the search. So there are a lot of graphs are there, but let's say you want to search something within or deep dive into a particular graph. So all the search analytics space is becoming popular, and then you should be able to query that data from this analytics and visualization platform. So that is a trend in this search analytics and query services is a recent addition in this space. Yeah, but at least the stream data processing in AWS it is Kinesis Analytics. In Azure there are multiple tools. Combination will give this solution where Azure Stream Analytics, Data Lake Analytics, and Data Lake Store. So all these three put together gives you that data processing visualization or analytics. In the GCP space, it is data flow, and in this VA visualization, it is a AWS QuickSight, where you can see all the fancy graphs and other things. In Azure, it is the most popular BI, Power BI, and then the GCP it is Data Studio and Looker. Looker is a recent addition in the space in GCP side, and it's also an acquired company by GCP, by Google. Where it can give you all the fancy graphs and other things on the BA visualization. You can get fancy reports you can get. And this search analytics space, it is so if you were to search, I mean the search on analytics, it's not a normal search of data. It is search of analytics. When your analytics are there are so many analytics components that will be there. It is even difficult to search the analytics itself. So in that space, this cloud search, and in this space, even the ML-based integrations are now coming up, where you can search by various options, like you can talk and ask them to search, or ML can identify what is your requirement from the way you type. I think this was a recent edition that we were discussing earlier. The recent Amazon event that happened. So this is one area where you can, like how you do when you do a Google search, you can how you do a free flow of text to search something. So likewise, you can search free flow by typing free flow, and like AWS can drill down the analytics based on what you type, so it can understand and it can drill down your data in real time. So, but the common area problem in this space is that every time you need to change the BA, you need to again depend on some developer. So that is a generation 3 years back. But now the graphs can change every time and every minute. So any customizations or any drill downs that you need further, so it should be instant. So that area is getting popular, and you can also talk in free language and tell in free language, and it can understand natural language, and it can do the drill down for you. So yeah, so that kind of area is very getting popular, and the cognitive search is also an Azure space, and that is one area where you can talk or type, and it can do the analytics based on what you type or talk. And GCP space, it is cloud search. So, and this query service is Athena in AWS space. Athena is where you can one big problem statement is that it is it is possible to search a structured data because you can type an SQL query on a structured data. But if you want to query an unstructured data, for example, S3 bucket, you want to filter. Let's say you have complicated data structure or a folder structure or hierarchy in your S3 bucket. It should be possible to write an Athena SQL query, Athena query to even filter the data, just like SQL. How you write a SQL query? We can now apply this SQL query on S3 folder or S3 bucket. So Athena is a query service where you can filter the data by using normal SQL queries equivalent on a unstructured data. That is the keyword. So you can query on unstructured data. Same thing in Azure, it is data like analytics. GCP is all BigQuery. So the BigQuery is a more powerful tool. It can support the structured, unstructured, and it can consume, like it can look for your data, for your filtered data in petabytes of huge data and fraction of seconds. That is the power of this tools where it can query huge volumes of data and it can filter the data and get the data for you back, which otherwise takes a lot of compute. If you don't have, if you have to do it on your on-premise, it requires a lot of compute. But this cloud has the power to get that for you behind the scenes. So that's about the big data space, and this is not ML included in this. It is just big data and analytics. This ML area is altogether different space. So any questions here? Okay, let's move on. It is next is DevOps and application monitoring. This is very popular landscape in any cloud, and also growing very fast. This monitoring is becoming very important in your day-to operations requirement. I mean, day one is you will develop something. Developers will develop something and they will deploy. And after that, generally in a bigger organizations, operations team has to manage this production deployed versions.
So Sham.
Yeah.
So one point actually, mostly for Venkat and the rest also, on the data field, right? So data field is so vast, right? So we have seen the tools across the data field, right? But what is the space where you can get a job right now is not on the cloud providers tools. That is one point. Yes, from on-premise to cloud, that migration happened. That is maturing. They need people. That is one space. The more traction field is like there are SaaS tools, which is what is really giving the real innovation on that space. So yeah, try to look into the Palantir, Foundry, and Snowflake just for see if that of any interest to you guys or something like that. Because penetrating into these big data field is little harder. Penetrating in that field might be little easier. Okay, just 2 cents on that.
I think all these independent vendors, one of the independent vendors in this space, apart from this cloud guys, where they are taking a larger share. But I think at the end, the data is nowadays all in cloud. I think the cloud vendors realized
but
it.
the thing is nowadays with the SaaS products, those are all those are sitting on the cloud only. But it is basically not from the cloud providers. They are sitting on top of all the now Palantir is also having in the AWS version of it right now. AWS as well as Azure version. So you could take your data across the cloud. If you put your data in Redshift, you are tied to Amazon, right? It's same thing with the Synopsys is Azure, right? But if you want to have a portable data, right? So last week we discussed about that solution, right? How to keep your solution. You cannot go away from cloud, but at the same time neutral, so that if you're kicked out or if you don't like it, you should take your data and the code out and move somewhere else. That is where the SaaS solutions are shining now.
And I think mostly all of them are also nowadays working on open source solutions, not just data with the normal other Java, Python based implementations or normal web applications and other areas. So they're all developing on open source technologies, and just for the deployment side, they're coming to cloud. And this Kubernetes that we discussed in the last session, right? So that is almost making cloud native. So if your application is deployed on Kubernetes, it doesn't matter which Kubernetes, it works the same way, more or less, on the clouds. So yeah, I think even this big data is also I don't know how far it is, but very soon it will also this Kubernetes also will embrace big data in a full-fledged way at some point. Yeah, any other questions or points? Okay, let's move to the DevOps and monitoring. So as I was just mentioning, this data operations are becoming more popular, and also it is once the application is deployed into production, that's when the real issues starts. So the infrastructure can go down, or your application can go down, or memory as it can spike up. All or the sudden usage of the system where it will scale up or scale down. So, so all the issues, or the production issues or the operational issues will start from day two of go live. Right? So that's where you need to have some tools in hand to monitor, especially for the field operations area. So for that, the monitoring is becoming very so popular, and I think the Google side actually the recently introduced not very recently, but I think it's there for quite some time. I think they recently introduced version 2 and version 3 is coming, which is site reliability engineering (SRE). So I think the concept of how this operations will look like, yeah, from the experience of Google monitoring their production systems. So all that experience and good practices are documented in that book called SRE book. So I think that it may not be suitable for all the organizations, but those are some of the common good best practices or good practices that Google follows, and but that can be embraced if that suits your logic also. And yeah, I think that in that book it primarily talks about all the areas where how your monitoring solution should behave in the enterprise. In that space, yeah, I think all the providers have integrations to all the various other products within monitor various other products. So in that space, so AWS has a tool called CloudWatch. Then Azure is called Azure Monitor, and then GCP is operations. I think it's old name is Stackline. They recently changed that name to operations. But it is all this set like monitoring product. So this will more or less integrate with all the various other products within each provider. For example, all these products can talk to the networking area, it will talk to the production storage area, it can talk to the computing area. So it talk to all the products, and it gets the metrics or the health information from all these products, and they will consolidate everything in one place so that it is easy for anyone to look how systems are performing at any given time. So, so that is this product. And in this monitoring, so yeah, we discussed that. I think CloudWatch is a popular product in the AWS space. Every product, software product, has integration with CloudWatch. And especially in the logging area, the CloudWatch logs, which is a separate product, but in Azure it is the same monitor, Azure monitor. In GCP it is cloud logging. For audit logging, for audit purposes, so it is cloud trails in AWS. In Azure it is monitor, Azure monitor, and GCP it is cloud audit logs. And debugging purposes, it is X-ray, AWS X-ray. Here it is monitor, and GCP is cloud debugger. So this debugging is primarily these tools are now helpful to even debug production applications. That is a new trend that is coming off late. I think one of the common problem these days is that from our past experiences, we know our only source of debugging a production issue is the logs. So logs are the first starting point from which we start our analysis. But it is really not possible to simulate. So most of the issues, it is difficult to simulate first of all. So simulation takes simulating the problem in production. So problem would have occurred in production, but first for any developer or production support person, first thing is to simulate the problem in a dev or other QA environment or staging environment. So for that to simulate that scenario, you need to have a lot of what happened at the time, what was the stack at the time when the issue happened. Like the stack, it includes your memory, CPU, storage, and also at what point you want to do a debug or put a stopwatch and find the issue. So that is becoming, it's not possible nowadays in the production system. But I think this cloud area, they understood the problem and they brought some tooling where you can take snapshot of the scenario wherever some issue happened, and you can taking that snapshot. You can at any given time you can take the snapshot and you can put it debug on the snapshot and trace the problem. So that way, all the other parameters, whatever on the day when the real production issue happened, they're all it's completely simulated for you. So that way you can debug the issue faster. So that is one a very innovative area where cloud has. I mean, so some areas are really very interesting. So where the developments happen. So yeah, this is one area where very very interesting. Also, performance tracing. Performance is one of the common. It's very difficult problem to trace, but one of the time-taking process. Any developer can understand this. So, but tracing a performance, the performance could be it could be an application, or it could be a database, or it could be some data transfer over the network. So it could be anywhere. Identifying that would be very tricky. But I think there are all these cloud providers have tools to do that. X-ray again performance tuning, and here it is cloud trace. In Azure space, everything is monitored. So I think monitor is a pool of many things into one. So and profiler, application profiling is also very important, especially where your code is performing well or where your code is not performing well. So what are the runtime issues? And it's difficult to find the runtime issues because unless the code is running, only then you can find some of the issues in the code. So all these profiler tools will help you to get that fix that issues. So this Code Guru, AWS Code Guru profiler is one such area which can help you to do that. Again, GCP is the same name, Cloud Profiler. Code repo, for the source code, where you want to put all your source code in one place, like a GitHub equivalent. So it is code commit, AWS code commit, and Azure it is Azure DevOps repos, or GitHub repos. GitHub, as you all know, GitHub is now Microsoft's company, right? Microsoft acquired GitHub. So GitHub repos is an enterprise version of GitHub, so you can also use that. And the GCP, it is cloud source repositories. So the cloud source repositories where you can have integration to Bitbucket, GitLab, so and all those popular GitHub, all the popular vendors it has integration with. So yeah, and the code build. Again, it is building the pipeline, create a pipeline, and this is build your code and deploy it and performing a pipeline. So typically the Jenkins will be used. So the equivalent to that in the cloud space, the cloud build, cloud deploy, cloud code pipeline. These are the AWS solutions. In Azure it is Azure DevOps, and in the GCP world it is cloud build. And next is artifacts, like where do you store the binaries or the Docker repos, where do you store it? So somewhere it is code artifact, where you generally store all the codes and binaries, everything you can store here. But generally you store binaries not for code. Code is like that, this place. You store it in repos, code repos. But the artifact is primarily the deployable units. Binary formats. So that is our code artifact, AWS code artifact. In this Azure, it is the Azure DevOps artifact and GitHub packages. The packages is different, GitHub repos are different. So those are different components in GitHub. And in the GCP one, it is artifact registry. So yeah, so then what will happen is there will the source code will be there in this area, and every time a developer makes a commit to the code to the Git, automatically this pipeline that you configure, the CI/CD pipeline that you configure, so that will be triggered, and it will do the compilation, generate the binaries, and then deploy it into the respective Azure components. So that will be done, and finally the final deployable units, which are artifacts. So the binaries will be stored in this code artifacts. So that completes the code building, code commit, code build, and then storing the artifacts. And in addition to that, the developer tools also are there. So where the developer tools will help you to, for developer to integrate all this tooling with your popular IDEs. So all these tools that you spoke. So using developer tools, you can integrate them into your own IDEs, or you can run them standalone. So all these tools will help you to help the developers to integrate this infrastructure into your day-to-day tooling. So yeah, so here it is cloud developer tools, including cloud code. And then I think these things, this command line tools, we can also do everything in CLI command line. So AWS command line interface, Azure it is Azure CLI or Azure PowerShell, and GCP is Cloud SDK. Cloud Shell, you can also do the same thing in the shell environment. So AWS Cloud Shell, Azure Cloud Shell, Cloud Shell. PowerShell, which is very popular Windows ways of automating or scripting. It is very popular in the Windows Microsoft ecosystem. So especially for that, PowerShell, Bash, PowerShell tooling. So there are a lot of tools which supports PowerShell. AWS, it is AWS tools for PowerShell, Azure PowerShell, and GCP PowerShell, PowerShell, and automation of the cloud tasks. So you should be able to automate all this pipeline, code pipeline, or infrastructure creation, infrastructure as a code. So you can use cloud formation, AWS cloud formation, or the AWS system manager for automating the cloud DevOps process. And here it is in Azure it is Resource Manager, VM creations, and Azure automation. I mean, definitely if you look at, if you remember that we have created this Azure ARM Resource Manager, where it created a JSON every time we create a VM. So you can create one VM, for example, and all the then it will generate a script or a JSON file. So you can copy that, and let's say you want to use the same configuration and increment the VM creation. Let's say you want to create 50 VMs with the same configuration. So if you create one, copy the configuration using ARM, and then you can use that JSON to create the rest 49 VMs, for example. So yeah, so you can copy that you can automate the creation process because doing it manually from the GUI will take time. So all this real life this automation scripts is what will be used by the DevOps team. Yeah, so VM extensions and Azure automation. So these are the areas where Azure still behind cloud automation tasks. GCP is GCP Cloud Deployment Manager. So and then next is automation, automate operations using templates. So we'll create templates based on popular DevOps template management tools like Jeff Puppet. Jeff and Puppet are open source template automation tools which are more popular. And Upswork in AWS is one such tool which helps you to create a template using Jeff or Puppet based template. In Azure, it is Azure automation, and it kind of thing. Yeah, that's about the DevOps and application monitoring. So summary: monitoring, logging, debugging, tracing, profiling, code, CI/CD, then that Cloud Shell, PowerShell, automation, and automation using templates. So yeah, this is the space where DevOps and application monitoring tools are there in various clouds. So any questions here? Okay.
So after this, what is the next section, Shah?
Yeah, I think this is more on management. I think okay.
Okay.
So, but
Let's cover the management, then we'll have a discussion.
yeah, sure. Yeah. So yeah, this management is a space where you have all the tools, you're using all the resources of cloud, but how can you, someone want to see a report or your management wants to take a report of your cloud usage, our management is looking for a building report. So these are tools which will help you for the management to get insights onto the usage of the cloud. So so it's not just the billing or the cloud billing part. It also has some tools which will help you to reduce the risk or mitigation or recommendations based on the usage. I think ML is a lot benefiting in this case where that all these cloud vendors have integration to ML where it can monitor your usage and it gives recommendations to you more in terms of security or cost reduction or doing upgrading to better components. Or upgrade to a higher versions. It gives a lot of. It will basically completely watch your usage and based on that it will give recommendations. There's a new trend in this space. But yeah, but looking at the management aspect, security and risk management is one area. So AWS has AWS Cluster Advisor, so where it can monitor all these things. This category monitors your usage and give recommendations, and also at the security and risk management aspects. So Azure it is Azure Advisor, and GCP is GCP Security Command Center. As the billing report, want to see the usage and generate the monthly billing report for the generate cloud usage, AWS usage and billing report, Azure billing API, and GCP cloud billing. So, and the console. Again, management also the infrastructure will see all the resources of usage from console for UI. AWS management console, and Azure portal, and GCP cloud console. Then this migration to cloud. In this space, we have, I mean, there are a lot of tools which you have to in this space where you want to, once you see, want to track the migration of your data to cloud. This AWS is an application discovery service. In Azure is Azure Migrate, and the GCP is assessment and migration. The monitoring space, it is EC2 System Manager in AWS, Azure Monitor, here it is GCP operations. Dashboard, you want to see the dashboard, primarily your health of your components. Because the cloud components also can go down because of the network issues or some data center being down. So you want to see the health of your cloud resources itself. So all these guys have dashboards. So personal health dashboard, AWS has personal dashboard, Azure resource health, and GCP is GCP cloud status dashboard. These dashboards will give information about in which location there's any downtime. It can give you that there is a downtime in this location. And of course, this is first thing is if something is going down in your application, first thing is to come and visit this dashboard to see if there's any downtimes in the cloud side itself. So the first place to look at from helpful for operations also. Log train. Log train is like looking at the logs summary or training of the logs. In that space, it is AWS Cloud Train, Monitor, and operations here. And application insights. You want to get a hold of how your application is performing. Is it management interested to see how the application is performing? Are there how many errors happen? How many issues are there? So summary of that you can get with the AWS CloudWatch. There is Azure application sites, and GCP is operations. Cost management. So you want to get a view of the cost by department or by BU business unit. So you want or by resources or by region. So various options are there. So you can get the details of cost using AWS Cost Explorer, Azure Cost Management, and GCP is GCP Cloud Reports and cost saving reports. So yeah, that's a summary of this management tools. I think it's actually big here. I think.
Yeah. So on the management, I have a very interesting use case to share in Pacific Gas and Electric Utility